Hi everyone, we are Group 7, and my name is Patterson. Our group members have Wang Kaixin, Xin Ailing, and Liu Yuhan. Today we are going to discuss about page replacement algorithm. Here is our question. We need to consider the following page replacement string 021640103121. Assuming a spacing scheme with 4 frames is initially empty. In this question, we're gonna use two methods. The first one is first in, first out, and the second one is the optimal. Now we start to solve the question by using the first in, first out. First in, first out is to replace the oldest page. We got 4 frames, so for each frame we can insert 1 page. We insert the first number 0 into the empty frame. Later 0 becomes the page 4. The yellow frame represents the page 4. Page 4 is the page that only appears for the first time. Next, we insert 2. 0 no longer is the page 4, but 2 becomes the page 4 now. Later, we insert 1 and 6 into each empty frame to be page 4, respectively in 3rd column and 4th column, and the other numbers are the normal page. Now we're gonna insert 4, but the frames are full and is not available in memory. In this case, we need to replace the oldest page. So we're gonna choose the page that is first in the memory. There are some sticks above the table. The one that is the first represents that is the oldest. The first one is 0. Later is 2, 1, and 6. We can see that 0 is the oldest page, so we replace it as 4. And then 4 becomes the page 4. We insert 4, 2, 1, and 6 into each frame. Then 0 comes, but it is not available in memory, so we need to replace the oldest page. We can see that the first tick is 2, so we remove 2 and then insert 0 into the memory, and 0 becomes the page 4. We insert 4, 0, 1, 6 into each frame. Next, we're gonna insert again 1. But 1 is already in the memory, so we just insert again the numbers like normal. Insert 4, 0, 1, and 6 without any page 4. Now we're gonna insert 0, but 0 is already in the memory. Just like we did before, we just insert again the numbers 4, 0, 1, and 6 into each frame without any page 4. For here, we want to insert 3 in the memory, but there are no more empty frames anymore. Therefore, we need to find the oldest page. As we can see, 1 is the first stick as the older page, so we change it to 3, and 3 becomes page 4. We insert 4, 0, 3, and 6 into each frame. Now, we need to insert 1 into the memory, but same things. The frames are full and is not in the memory. In this case, we need to find the oldest page, and then the older page is 6. So we remove 6 and insert 1 into the frame, and 1 becomes page 4. We insert 4, 0, 3, and 1 into each frame. Later, 2 is coming, and we also need to insert 2 into the memory. But 2 is not in the memory, so we do the same things again. Find the oldest page and replace it with 2. In the memory, 4 is the oldest page, so we remove it and insert 2 in the frame. Then 2 becomes page 4. We insert 2, 0, 3, and 1 into each frame. Lastly, we want to insert the last number 1, but it's already in the memory, so there are no change. Insert again 2, 0, 3, and 1 in the memory without any page fault. Now we need to count the total of the page fault. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 page faults in this memory. That's all. Next, I will pass to Wang Kaixin to do the second method optimal. Thank you.
Hi, my name is Wang Kaixin. Now we are going to solve the question by using optimal. What is optimal? Optimal is to replace the page that will not be used for the longest. How do we do? First, we draw a table which contains 4 frames. Next, we insert the first number, which is 0, into the empty frame, and the yellow frame represents the page fault. What is page fault? Page fault is the page that only appears for the first time. Next, we can saw the first frame is not empty. There has a number 0, so we insert 2 in the second frame, which it is empty. Then 2 will become page fault. Later, we insert 1 and 6 into each frame, empty frame to the page faults, respectively, in third and fourth column. Now, we are looking for 4. But our frame already full, so how do we do? First, we're looking for the first number 0. We can do the optimal by to replace the page that will not be used for the longest. That means we are gonna to look at the further. First, we look for 0. Further already have by near. Next is 2. Also have. Next is 1. Also still have. And 6 didn't have at the future. But we can saw it if 6 has the future at here, so we're gonna to choose 2. But now 6 didn't have at the future, so we can replace 6 by 4. So 4 will be page 4. Next is 0. We can look further have a 0 beside only, so just copy all out, and this will become page hit. Page hit is mean didn't have any page fault. Next is 1, also have in this frame, so this also be page hit. Next is 0, 0 same with before, so this also become page hit. Now we're looking for 3. 3 didn't have in this frame, so we gonna to looking. First one is 0. 0 doesn't have future, so it's looking back. Next is 2. 2 have the future at here, so stay back, and 1 same. But we found that 4 also didn't have future, we need to look at back. So how do we do is looking for 0 and 4, compare it. Which one is the oldest one? Is 0 or 4? 4 only have 3 oldest one, and 0 is the oldest one which from start. So 0 will be replaced by 3. 3 will become page 4. Next is 1. 1 has in this frame, so just copy it, and this one will be page hit. Next is 2, same with before, also copy it and become page hit. Next is 1, same with before, also have in this frame. So this one will be page hit. After we do it all, we need to calculate page 4. 1, 2, 3, 4, 5, and 6. So that means this optimal method done by this question has 6 page faults. This is all of my presenting. Thank you.